Today we're going to talk about the chain rule for polynomial functions. I like to think of this as the blow pop method. You know how you have a sucker or a lollipop, blow pop, and inside the center of your blow pop there's some gum. But in order to get to the gum, you have to take off the wrapper. You have to eat or bite through the hard candy, and then you can get to the center. So we're going to have to take this off in layers. So for example, if we were to rewrite the function y equals the square root of the quantity x squared plus 1, we rewrite that so that we can use the power rule. We have the quantity x squared plus 1 all raised to the half power. Now, if we look at the original function, the square root of x squared plus 1, we get this graph. Now this almost looks like the absolute value function, and it is very closely similar. But right in here, we actually have a zero slope instead of an undefined slope, and we have a slope that's really close to being 1 and a slope really close to being -1 on the left-hand side. Now, if we look at the actual derivative of that function, we get the one you see here. Notice that if you try to just do the power rule, bringing the half down and just reducing the power, you would get this function. Notice how drastically different that function is. This is the wrong one, so this is no, compared to what is the correct derivative. So there's a different rule to use when we have our lollipop or our blow pop, and it's called the chain rule because it involves a composition of functions. This is not a multiplication problem, but a composition problem. Okay, so the way that the chain rule works is that you have a function defined as a composition. We're going to take the derivative of the outside function, and we're going to leave the inside alone. So we're just taking the wrapper off. So we're just taking the derivative of f and leaving the internal part of the function. And then we're taking the derivative of the inside part and multiplying that. This could chain together in multiple patterns if we needed it to. So what you want to think about this composition as is you're going to remind yourself that when we had trigonometry, for example, if we had the sine of 2x as a composite function, not a multiplication, but composition, the 2x represents the angle of that sine function. You can't simply move the 2 out to the front side. That's an amplitude. That's a multiplication problem. Not the same thing. So remember, in order to try to take this angle out, we had to use trig identities. So in order to get rid of it being a 2x, we had to do trig identities. Okay, so the same kind of thing would occur if you try to change a composition with other things. You would have to have an identity or a simplification to make this nicer. So we're going to think of the above function that we had as the square root of x composited with x squared plus 1 on the inside. So remember, our original function at the top of the page was the square root of x, and we're going to composite inside of that the x squared plus 1. So that makes the function at the top of the page a composition like this one. So if we were just doing f prime of x, f prime would be 1/2 x to the -1/2. That's where we get this part. G of x would have a derivative of 2x. So that's where we get this part. Remember, the rule is that you have to keep the composition inside the outer layer. So when we take the derivative of f in terms of x, we would have to rewrite that with g on the inside because the original function of f had g on the inside. And then we multiply times the derivative of g. Now this looks a lot more complicated than it has to be. I like to think of this, again, as taking the layers off of my blow pop. In this particular case, this wouldn't be a blow pop so much as just maybe one of those cheap dum-dum suckers. So we do have some candy on the inside. I'll make this one pink. It's a lolly there, right on the inside. But all it has on it's a wrapper. So you take the wrapper off, you get to eat the lollipop. There's no third center of gum. So I'm going to think of this the same way. So my derivative, dy dx, which I can write as y prime as long as I'm very careful with my notation, says I take the derivative of the outside wrapper. Well, the outside wrapper is the 1/2, and then that would become raised to the negative 1/2. I'm not throwing the lollipop away when I take the wrapper off. I'm keeping the lollipop, so I'm going to leave it right there. After this wrapper comes off, then I'm going to multiply by the derivative of the inside, which is the lollipop, 2x. So the derivative of the outside, keep the guts, times the derivative of the inside. So again, that's the derivative of the outside, keep the guts. If you take the guts out, you've basically killed it, times the derivative of the inside. Now, if this were a free response question, I would be completely done. But most of the time, a question that's just asking for the derivative and not asking for any other steps is going to be a multiple choice question. So I would simplify. And right now, I would have a 1/2 times a 2x. And that negative power is the only thing that's going to go to the bottom. So just this part ends up needing to be on the bottom. It's a square root still, but it's on the denominator of the quantity x squared plus 1. So my final simplification for y prime, the 1/2 times 2 becomes just x. And then we have the square root of x squared plus 1. I like to mark off my questions as I go to make sure I'm not continuing to do extra derivatives. A lot of students get to this part and think they need to multiply by 2 again because it looks like it's inside. But in reality, we only had 2 layers this time. So we only did 2 derivatives. Okay, so another example. I'm not going to break this apart into different pieces anymore. I'm just going to rewrite so that I can use the power rule. 4 minus x squared is the inside part. That's my lollipop. And the wrapper happens to be a 1/2 power again. So in doing my derivative, I'm going to do just the outside part. And just the outside part is 1/2 to the negative 1/2. I leave the guts the way that they were. And then I'm going to come in and do the derivative of the inside. And the derivative of 4 minus x squared is negative 2x. All that remains is simplification. So using the algebra, I have 1/2 times negative 2x is negative 1x. The negative power says this entire piece belongs on the bottom. And I would very likely to see that as a multiple choice. returned to the radical format instead of the power. Now, an example of how this would work in a word problem. If David can type twice as fast as Mary, and Mary can type 3 times as fast as Joe, then David can type 6 times as fast as Joe. This is really basically the chain rule. So if I were to think about the units, dy du times du dx, it kind of cancels to give me dy dx. Just another way of thinking of the chain rule. So again, that's the idea that if I have a function in terms of something else that's not plain x, a function inside of a function, I take the derivative of the outside in terms of the inside function. So dy du would be f prime of u times du dx, so times the derivative of the inside, which is in terms of x. So take the derivative of the outside, leaving the same original guts, times the derivative of the inside. Now, what that would look like in an AP problem. They're giving me y, they're giving me u, they're asking me for dy du. That means they're asking me to recognize the dy dx is the derivative of y in terms of u times the derivative of u in terms of x. So they're wanting me to recognize that I could split that apart or think of it as the chain rule. So now, for this, I can literally take the derivative of y in terms of x for this piece. So that means the derivative of y in terms of x would be just 2x, because I'm taking the derivative of y in terms of x. dy du is the question. I don't know what that is yet, so I'm not required to fill anything in for it. I'm just going to keep him there. He's my unknown. Now the derivative of u with respect to x requires me to come here and take the derivative in terms of x. And the derivative of 2x minus 1 is just 2. Now I can do the algebra to solve, dividing each side by 2. I get x equals dy du. So the correct answer is just D. Now most of your questions are not of that format, although that is a formula you have to memorize so that you can use it if you see it. It's more of a flashcard memorization, so that if you see them ask for this dy du guy, you're going to know it came from here. But most of them are in this format that we're accustomed to now doing as the lollipop wrapper. So we have an inside lollipop, and we have the outside wrapper around our lollipop. So our derivative is to take the derivative of the outside, 3/2, subtracting 1 becomes positive 1/2, leave the guts, don't throw them away, and don't change it. You can't change the interior of a function without identities. Times the derivative of the inside, so times 4. Again, if this were an FRQ, I would stop right there. On a multiple choice, which is what this problem would probably be, 3/2 times 4. 3 times 4 is 12. 12 divided by 2 is 6. And in this case, this is not going on the denominator. We only put them on the denominator when we have a negative power. So this is just a regular square root. It's just not the third power anymore. So that's the difference, is we reduce the power. And that would be my final answer on a multiple choice. Okay, so some classwork on using the chain rule. I'm going to take the derivative of the outside, reduce the power to 9, so subtracting 1, times the derivative of the inside. So my derivative is 20 times 2x plus 9 raised to the 9. Sorry, 2x plus 1. Got a little excited about the 9. 2x plus 1 raised to the 9. I'm going to skip 2. You can try that one on your own and check your answer on the answer key that's posted. I'm going to rewrite number 3 as the quantity x cubed minus 1, all raised to the 1/2 power. Then I could work the problem very similarly to the one that I did for number 1. I'm going to take the derivative of the outside. So that reduces us to the negative 1/2 power times the derivative of the inside. Again, that would have been my free response answer, but just to practice our algebra, 1/2 times 3, 3/2. The x squared is not a negative power, it belongs on the numerator. The x cubed minus 1 is raised to the negative 1/2 power, so that belongs in the denominator, like so. We're going to jump over and do number 4, since it's a quotient rule. I'm going to write my low as x minus 1 to the 1/2 power. My high is 2x. The derivative of low is 1/2 quantity x minus 1 to the negative 1/2 times the derivative of the inside, which just happens to be a 1. The derivative of x minus 1 happens to be 1. The derivative of high is the derivative of 2x, so that's 2. So now I'm going to do my nursery rhyme. Low d high minus high times d low. Now the high times d low is 2x times half times this power. 2x times half is just x, but now I have x minus 1 to the negative 1/2 there. So low d high minus high d low over the square of what was below. Now the square of the original low just cancels the square root, so I don't have a square root anymore, just have x minus 1. Now if I were trying to simplify this out, I have to remember that the negative power is not with both terms, it's only with the x term. That would mean that I need a common denominator in the numerator portion. So I would need to multiply by a giant number 1 right here. And my giant number 1 is going to be the square root of x minus 1 over the square root of x minus 1, because I need that common denominator. When I multiply a square root by the matching square root, the square root cancels. So now I have 2x minus 2 minus an x. So 2x minus x leaves me with x. I still have the minus 2. Now this was just my numerator portion. That means that my denominator has to be the square root of x minus 1 and the x minus 1. So that's really x minus 1, 1.5 times, or to the 3 halves. So I could see this as x minus 2 square root x minus 1 cubed on the bottom, or I could see them leave it as the power. So either of these would be a good final answer. Okay, for number 5, we have a product. So our first term has a derivative of 2 x squared plus 3 to the first power times the derivative of the inside, which is 2x. Our second portion has a derivative of just 8. Remember, for the product rule, we cannot just multiply those together. We have to do our little wife swap. So h prime of x is the original first term with the alternate derivative plus the original second term multiplied by the alternate derivative. Now I'm going to go ahead and simplify this derivative when I write it down. 2 times 2 is 4, so I'm at least going to write it as 4x and x squared plus 3. Now for this one, that would have been my FRQ answer. If it were a multiple choice, I would keep going. I would not distribute this out. I would pull out the GCF. X squared plus 3 occurs in both parts, so I know I can pull out an x squared plus 3. 8 is in the first term and 4 is in the second term, so I know I can pull out a 4. So if I pull this out of the first term, that leaves me with 2, and then the quantity x squared plus 3 to the first power still remains. I pulled out the 4 and the x squared plus 3, but that still leaves me with an x and an 8x minus 1 term. So still simplifying for my multiple choice. 4, quantity x squared plus 3. If I simplify, I have 2x squared plus 6, 8x squared minus x. So 2x squared and 8x squared is 10x squared. Plus 6 and minus x, just minus x and plus 6. They don't combine because they're not like terms. So that's it. That's all I can factor out. So this would be much harder if you distributed everything and then tried to factor. You're going to see them in factored form on the AP exam. Okay, so I'd like for you to try the other even ones on the page and check your answers on the key. So in this one, I think I'll do number 8 with you just because I think it's a little tricky. Remember, E is a constant. People get a little confused about that because they confuse that with the function e to the x. That x thing, that's what makes it a function. Okay, so e is just a constant. Pi, also just a constant. So when I take the derivative of the outside, I'm just doing the 3 power. So the third power comes down. I keep the guts and reduces to the second power. The derivative of the inside, think of this as 2x plus 3. E is a 2.718. Kind of think of him as 3. Please don't round him off to 3 on any of your problems. That's not okay. But you can kind of imagine him being a 3. Not on your paper, just in your imagination. 2x plus 3 has a derivative of only 2. I've done the 2 layers that I have, so I'm done. That would be my FRQ answer. I would be done with that part. If it's a multiple choice, they're definitely going to simplify because you're really only simplifying the 3 times 2, which makes 6. And they're not going to FOIL these out. Remember what I said, they're going to leave them in factored form typically. Okay, so let's look at number 10. I'm going to rewrite my function. It's the quantity x to the 4th plus 1 is the inside of the composition. The outside of the composition is the cube root, which is the 1/3 power. So my derivative says take the derivative of the outside, which is 1/3. The quantity x to the 4th plus 1 is now raised to the negative 2/3 because we're subtracting 1. We're not done yet. Derivative of x to the 4th is 4x cubed. Again, that's my FRQ answer. I wouldn't continue on from there if it's a free response. On a multiple choice, the 1/3 times the 4 stays 4/3. The x cubed is a positive power, so that stays in the numerator. X to the 4th plus 1, I'm going to put in the denominator. They tend not to write the ones that have powers and roots in the denominator in that original format. It takes a little less space to leave it this way, and that's pretty much how the AP exam's written. Leave it the least amount of space. Okay, so I want you to practice for numbers 7, 9, 11 and check your answers. We're going to rewrite number 12. Technically, we have x minus 1 to the 1/2 inside another half power. Yes, we can do a triple layer like that, but if we can simplify, we should. And remember your algebra 2, a power to a power you multiply. That's really just the 4th root. So my derivative is taking derivative of the 4th root, which is 1/4. The inside, subtracting 1, I get negative 3/4. So I did the 1/4 part, times the derivative of the inside, which happens to be 1. That's kind of nice. Again, doesn't even matter if I have a little times 1 out there. I'm still not simplifying that for an FRQ. If it's a multiple choice, 1/4 times 1 is 1/4. The negative power belongs on the bottom, and they're not typically going to rewrite those fractional ones unless it was just a 1/4 power or a 1/3 or a 1/2. They're not going to do the proper fraction ones typically if there's anything other than a 1, or even the improper ones for that matter. So that would be my multiple choice answer. Okay. I'd like for you to do the challenging one for 13 and check your answer key. We'll look at 14 together. So I'm going to rewrite this. I'm going to move 2x to the 5th minus 7 to the numerator, but then I have to indicate that it's now a negative power because it's in the wrong spot. See if I can fix my handwriting a little bit there. Technically we had a 1 on the outside, but we can write it there. We don't have to. Now when I take the derivative, the negative 3 comes down to multiply with the 1, so it's just a negative 3. 2x to the 5th minus 7. And now the most common mistake is people move towards 0 and say negative 2. They think 3 goes to 2, but remember we're subtracting. So subtracting 1 becomes more negative, which means negative 4. So we've done the outside. Now we're going to do the inside, and the inside is 10x to the 4th. That would be my FRQ answer. For my multiple choice, the negative 3 times the 10 makes negative 30. X to the fourth is a positive power, stays in the numerator. But we have a quantity to the negative 4 power, which we need to move to the bottom. Okay. Now for each of the following, it says find the equation of the tangent line at the indicated point and verify by calculator. So what I want you to do is to put this part into Y1 of your calculator. You're going to graph it first. And then you're going to use the draw feature of your calculator. So if we place the square root of x squared plus 2x plus 8 into our calculator, we're going to graph that. Then we're going to use the draw feature. The draw is the second, the blue, above program. So we're going to second draw. We're going to choose a tangent line number 5. And then it's going to ask you where. Well, we don't want to do x equals 0. We want to look, we're going to do x equals 2. So we're going to type 2 in for x and press enter. Your calculator will then draw the tangent line to the curve at x equals 2 and tell you its approximation for the answer. So for example here, my calculator got approximately 3/4 x plus 5/2. So my calculator thinks the correct answer for the tangent line is y equals 3/4 x plus 5/2. I can actually do the work because I'm not going to have a calculator on 2/3 of my exam to figure out if I know how to do this without the calculator. So again, my calculator thinks the answer to the tangent line question is y equals 3/4 x plus 5/2. I'm going to rewrite my equation, the given equation, not the tangent line, as y equals x squared plus 2x plus 8 to the 1/2 power. Y prime is then 1/2 x squared plus 2x plus 8 to the negative 1/2 power times the derivative of the inside, which is 2x plus 2. So y prime is 1/2 times 2x plus 2, which becomes x plus 1, over the square root of x squared plus 2x plus 8. Now our slope of the tangent line at the point where x is 2 and y is 4 is 2 plus 1, which is 3, over the square root of 2 squared plus 2 times 2 plus 8. So it's 3 divided by the square root of 16, so lo and behold, 3/4. So if I were to write my tangent line, y minus 4 equals 3/4, parentheses, x minus 2, close parentheses, using point slope form. Now if this was my FRQ, I would leave it in that format. If I'm just checking my answers with the calculator, I could distribute to get 3/4 x minus 6/4, or 3/2. Then if I add 4 to both sides, notice I get y equals 3/4 x, and 4 minus 1.5 is 2.5, or 5/2. So just checking to see if I get the right answer, or at least the right slope. Typically, if you're going to leave your answer in point slope form, which I would definitely prefer, since that's what you should be doing for the AP, at least use your tangent line to figure out if you have the right slope. Okay? I'm not going to go through B and C with you. I do want to show you how to put letter C into your calculator, just for practice. So if I go to my y equals, in order to put this into my y1, I'm going to do alpha y equals, because that is my f1, which you can't hardly see on this little green part, gives me fractions. Okay, so I'm going to use that feature a lot. This particular case, I want to do the square root first, which is the blue second button, and then I'm going to put the fraction inside that square root. So I have 3x minus 1 in the numerator. Notice that it gives me a right arrow, so I'm going to right arrow 2x plus 1. Notice it's still giving me a right arrow, so that means I need a right arrow out, and I can see that my function's complete. So the other way to do this without graphing, there's a possibility, you can do the alpha zoom, alpha F2, the table set here. So go to your n deriv, numeric derivative, and you're going to do the derivative with respect to x of the y1 function, which is alpha f4, derivative with respect to x of y1 at x equals, in this case, -1. But this is just to check your derivative. This is not to do the whole problem. You need to be able to do this problem without your calculator. Finally, we're going to use this information to go through 18, 19, 20, and 21. Okay, notice the difference between 18 and 21. 21 is a composition. Not a multiplication. 18 is multiplication. So for multiplication, we're just doing wife swap. So f of x goes with g prime plus g of x goes with f prime. Now we're evaluating each of these at x is 2. So h prime of 2 is going to equal f of 2, which is -3. G prime at 2, which is -2. G of 2, which is 3. F prime at 2, which is 6. So that would be my free response answer on a multiple choice. I would get +6 plus 18, so 24. Do a similar process for your quotient rule, but you need to practice your quotient rule. Since the new thing we're doing was chain rule, we'll go through 20 and 21 together. So the chain rule says that we take the derivative of the outside, leaving everything else the same, times the derivative of the inside. So h prime 2 is 3. F of 2 is -3, and that's being squared. And then f prime at 2 was 6. So that would still be my free response answer. I wouldn't continue from there. For multiple choice, excuse me, this is -3 squared is +9. 9 times 6 is 54. 3 times 54, 162. So again, that's 3 times 9 times 6, 54 times 3, 162. So one more time with our chain rule. The chain rule says when we have a composition of functions, we take the derivative of the outside, keeping the guts. You don't change it to f of x. It is not f of x. It's f with g inside. Times the derivative of the inside. Now that one just has a plain x inside. So g prime x. At x equals 2, we have to be a little bit more careful here. F prime is evaluated at g of 2. G of 2 is 3. G prime is being evaluated at 2. So x is 2, not the inside part. So you got to be careful on that part. So x is 2, g of 2 is 3. So we need f prime 3, which is 4, but g prime at 2, negative 2. That would be my FRQ answer. My multiple choice answer is negative 8. Okay, so I'm leaving the last 2 pages for you to try as part of your classwork. You should definitely go through these problems. Everything that I give you as a printout or as an uploaded PDF for something to be classwork is definitely a priority for preparing for your quizzes and tests. So I've given you the answers, which is one of the reasons I'm not going to go through these problems. I'm telling you what the correct answer is. So you're going to know right away if you got the question right or wrong. You can double check your work to see if you missed something small, maybe it was arithmetic, or if you missed something bigger and you need to look at the answer key that I've posted to see if you understand the material, not that you just messed up something small. Okay, so the last 2 pages are for you to finish and check on the answer key.